Hi, I would like to introduce the QR quantum refinement project. We want to refine biomolecules, which is done with a restrained optimization of the target function T with respect to model parameters. Target function consists of both the experimental data and restraints which contain chemical information, such as bond length and angles and so forth. We want to fit the model to experimental data as best as possible without violating available a priori knowledge about the molecule. Those restraints are needed because the experimental data might be of insufficient quality or missing for parts of the molecule. This is done usually with a force field-like approach, where you have a simple function for the restraint, which turn out to be insufficient to describe reality in many cases, and the idea is to replace those restraints with information from quantum chemistry calculations. So your usual DFT-D3 or GFN-XDB calculation. QR project is an international cooperation between Phoenix, Lawrence Berkeley National Lab, the ICQMS Center at Shanghai University, and the Institute of Biophysics from the Czech Academy of Sciences. And we are collecting crystallographers, quantum chemists, and research software engineers to do this project. It's a quite young project. The proof of principle was published 2017. Our approach of solving the QM scaling issue with an automated fragmentation approach was published shortly after. We can treat already full point group symmetry of crystals. And just a few days ago, we published that we can do real space refinement for cryo-EM structures. We're currently working on handling alternative locations. There are still many things to do in the future. The idea is that we will be able to refine complete PDB database in a semi-automatic fashion. This slide shows an example of a QM refinement of a small protein using the GPU code Hurricane. The standard phosphorus refinement here on the left shows quite poor hydrogen bonding, which is significantly improved using the QM refinement. QR project, it aims to do global QM refinement. We have no size limitations due to our fragmentation approach. We have no point group limitations. Soon we can handle alternative locations. We already can do crystal structures and cryo-EM structures. We're an open source project. We have a Python code written from scratch, built upon existing libraries like the crystallography toolbox or the ASE that interfaces various QM programs, and we aim to adhere to modern software practices. Important for the users is that it naturally integrates into a Phoenix refinement workflow. In the short term, we have to make the switch from Python 2 to Python 3. We are dependent how fast CCTPX and Phoenix are doing the switch. We're quite unhappy with the ASE engines we are using. We have to do some custom modifications, and we are limited in various ways. And we hope that switching to QC engine as the QM program backend will solve some of these issues. And I also would like to add Psi4 with Brian QC as a second GPU-driven program for this project. This is a quick overview, and if you want to know more, there are links here on this slide. And thank you very much for listening.